Okay, so this week we'll do introduction to Python programming, and hopefully we can get to just give an introduction to data analysis. But the Python programming would be a little, I think it would be more of basic maths actually. It would be more of the maths, just basic maths. So let's go. So the quote of the day today, the quote is from Daniel Keys Moran. He said, you can have data without information, but you cannot have information without data. So just having data sitting there, well, it's a good thing first, but you may not have information from that data. But if you want to get information, that's when you explore your data, you mine the data, you understand all the variables, everything within the data, understand what the data is saying, and then you are able to make meaning or get information from that data. So you can have data just sitting there on your database or whatever, but it doesn't give any information or even help the business, right? But when you want to get information, then you go and mine your data and do some exploratory data analysis there. So you cannot have information without data. Okay, so just to give today's outline for the class, we're going to refresh on functions and classes. I won't do much of this. We'll just go through the functions we talked about last time. I mean, highlight some. Okay, highlight some of the things that we talked about in the last class. Those that went for the physical class, I believe you had the opportunity to go through this. I got feedback that some people were still struggling with the indentation in Python, but I think hopefully that was cleared for you in the physical class. Then we'll do more of basic maths for machine learning today, just to set the background for the subsequent weeks on exploratory data analysis and then supervised learning before unsupervised learning. Then we're going to just talk briefly on NumPy, then pandas, then set the stage for exploratory data analysis we'll do next week. Okay, so let's go. So just quickly review the functions and classes for last class. I believe if you watched the video, if you went to the class, you will see some of the things that we talked about last time. So we talked about functions here.
Well, Kiki, Fala.
If you just try to mute, please, so that you don't try to mute.
He had me shot to give up the case.
Mubarak, try to mute. Okay, so functions. So now we said that functions are Python objects that codes that do not run except they are called, right? And we created a simple function here for age increase. This simple function, we said functions can have arguments, right? So we create a function. Functions are defined with this keyword define. Then the name of the function, you can call it any name. Usually it's better to call it the name that explains what the function would do. And then you have some arguments within the bracket here, and then you have the block of text or block of codes that take action of what that function would do. But that code should be indented. You have to use indentation, proper spacing in Python. If not, Python would cry out. So let's check this function here. This function, this is a comment. We just want to print what this function does first and see. So if you call this function, we call the function age increase. So you call the function by its name and the brackets. If we run this code here, you see it runs the code within this function, right? But when we loaded this function into Python, nothing happened until we called the function before it executed the text within that function, the code within that function. Okay, then now we said, okay, if we add some argument like age, so that when we get that age, we want to add 5 to that age. Anytime we get a particular age, we add 5 to it. And then we have a new age for that person or whatever, and then we return this value here, new age. So return that value there, you'll see Python would run that and return, we'll add 5 to that age and return the value. So we said if we add 5 to 25, for example, that means we're calling 25 as the age here. If we run that, we're going to get, oh, sorry, I didn't load the function yet. Okay. So if you load the function first, then if you call that 25, it's going to add 5 and return the value. Okay. Then we talked about also classes. So classes are more of like a collection of objects, like an object constructor. So you can use a class that has maybe different functions within it. Those functions within the class are called methods, right? So like the assignment I gave you guys to do, we said you would get create an object for a car with different attributes, and then do different things within that, create different methods within that car class to do different things, right? So that's just similar to this example here. We said, let me go down a bit. Yeah, so we said you can initialize that class. So anytime you want to create a student, for example, you're going to have name, age, and gender. So you're going to specify the student's name, the student's age, the student's gender. So if you can store the name of that student or these attributes of this class within the object self, we can store within self. So once you store it within self, it's going to be a property or an attribute of that class object once you create the object. So this one was storing self.name equals name, self.age equals age, then self.gender equals gender. So anytime we want to use this name from this initialization here, we can call it within any method, or we can call it within any method down there. Though I'm not sure we did that. Okay, we did that for this. So if you look at age increase here, want to create a student, we are creating a method here to increase the student's age. To increase the student's age. So we're still going to use that self constructor here. Then if we send age to this function, age increase, we said we can add 5 to that age, and the self.age, the age of that student will be increased. So anytime you call self.age after you have added 5, you are going to get the value of the student's age that you created initially plus 5. So whether it's car color or car whatever, you can just create a function like this. Then you change self.color to the new color that you want to specify, to the color that you specified there. Then we also did for add last name to the student to create a new attribute, which is last name. So if we create this class, we created a class now. If we run student with John is the name of the student. John is 18 years old, 18. John's gender is male, right? So if we call that class student and we give it the different attributes for it to construct John, if you run that, then you're going to have John, right? And we talked about how you can check for John, sorry, it's case sensitive, John.name. You will get the name which is specified, which is John. If you check for John.age, you'll get the age which is specified, which is 18. If you also check for John.gender, you will get the gender which is specified, which is male. So someone asked last time if we can combine, we can play everything, run everything at once and all that. Well, it's a good question. It's a good question, but it's not necessary. Program is also about organizing things and getting proper structure. So it's good if you can call the attributes one at a time. Okay, before I go further, are there any questions? Any questions at this point?
Hello, sir.
Yes, sir. I have a question.
Did you
Yes.
specify 18 in the first line, or where did the 18 came from? This
Okay, look,
18.
yeah, look, I just specified 18 here when I was creating the object.
Okay.
Yeah, this 18 here. So this 18 is, we're calling the class student, and then so anytime you want to create a new object, let's create, like you said, we can create a new student. I think we created another student. Okay, anytime you want to create a new student, right, you have to specify the student's name, the age, and the gender. Which are the attributes? Okay, fine, we'll come to you. Which are the attributes that will specify that this class needs to be constructed? Right, this part, we said we should go through this whole Python functions and classes to help people understand when we start using some classes of different Python libraries, right? Because you're going to use Python libraries and then you're going to call some of the methods within those libraries, right? So this one, let's say we want to specify, I don't know how's the question, would have used your name here, but it's okay. Okay, let's say Sarah equal to, want to create a new student. So if you are creating a new student, Python will ask for the name of the student, age, and the gender, because that's what this class needs. So the name of the student is Sarah. We can even put the surname too. Sarah Johnson. Right? Then the age will now be let's say 20 years. The age is a number. Then let's say the gender is female, right? So if you run that code, Sarah is already formed. So Sarah is here. So if you check for Sarah's name, it will give you Sarah Johnson. If you check for Sarah's age, it will give you 20 and so on. So there's someone else that had a question.
Sir, I
Yes.
have a question, sir.
Okay, is that fine, or so that I would know
Yes,
if
sir. Yes, sir. Is it fine?
Yes, please go ahead.
Okay, sir. In the class definition, that
Yeah.
self, can we change it to any other thing?
Good question. Yeah, so let's try. I know depending on the kind of class, you can also call it. Let's use CLS. Let's use CLS and try. I usually use self. That's the normal Python language. But I know if you are creating a different kind of class, you can use something different. So let's call it CLS. I think it will still work. Self is just the normal Python language, right? So you have to replace everything with that particular word that you're using. So if we use CLS, let's see, I think it will still give us the same thing. So we're creating that class with CLS now. So if you say Sarah.name, it will still give you the same thing, right? So it's the same, yeah, just normal Python language itself, but you can use whatever name. So far, you know that term you use there is what you will call that class with in all the methods. Yeah. Is that clear?
Yes, sir. Yes, sir.
Okay.
Thank you.
All right. Any other question?
Hello, sir.
Yes, please.
Sorry, please. This class.
I'm not sure
What
why I
is
can't
actually?
see your name. Okay,
My name
Benga.
is Benga.
Okay.
This class, what is the purpose, as in the intention of the class?
Mm-hmm.
You know, when you do function, we know that it is more of a mathematical calculations or like that. But this class, what do we intend to achieve? Is it that we want to achieve a table or a list of people or something like that?
No. So, okay. Yeah, you can mute. So the idea is the function is not necessarily like maths function. The function is just a block of code that does a specific thing, right? So it's a way to organize your code to do a specific thing. Like what we did before, it was just to print this before we added this function here, right? So it's just to do a specific thing. That's what a function is. So you now use a function within a class to also do create a specific object, right? So you're creating a specific object that will do some certain things. Like when we get into why this is important, when we get into something like pandas, for example, let me write something here. Pandas is usually imported as PD. Import pandas as PD, for example, right? So pandas has a method called read_CSV. If you want to load a CSV file into pandas, right, you would load this method that's within pandas, right? So when you load this method that's within pandas here, then you specify the name of the file, then pandas will load that file for you. So pandas has something like a method within it called read_CSV, right? So classes are used to construct libraries, they're used to construct objects, and it's just a bunch of different methods or different functions that do specific things. Okay? Is it clear, Benga?
Yes, sir. Thank you.
Okay. All right. So yeah, okay, let's go on now to the, so done the review of classes. I hope it's clear to everyone. Then I also am happy that the groups are now meeting. At least within your groups, you can also share knowledge. At least want to make sure that as much as possible, you have different opportunities to learn. Okay, so now we're going to, I just went to the beginning. Okay, so now we're going to go into the basic maths for machine learning, just basic maths to understand data, very basic. Then we'll go into NumPy and pandas. So there are three major types of data you see in machine learning. The three major types of data, whether in a supervised or unsupervised learning problem. Maybe later you may encounter different type of data like text data, if you are doing natural language processing, or like even music data if you are doing translations of music and all that. But types of data generally are numerical, categorical, or ordinal data. So numerical data is data that is sort of quantitative for quantitative measurement. So if you're looking at the height of people, you're looking at stock prices, looking at the budget of Nigeria. So those kind of things you're going to see numerical data. So this numerical data can be discrete, like integer, when you talk about counts, how many customers, how many employees, how many clients, those kind of things. So discrete data. But you can also have continuous data, like we talked about float numbers before in the last class. So floats, these are numbers that can take any value, can have decimals and all that. So how much rainfall in a day, for example, how much time did it take for user to check out? So time can be 6.30 seconds, for example, or 6 minutes, 30 seconds, depending on how you present the time, right? So time can be continuous data, stock prices can be continuous data. So discrete data or continuous data, that's numerical data. Then we're going to do a quiz after this, so just pay attention. So categorical data can be qualitative data that has no inherent mathematical meaning, right? It can be text data. It doesn't really, you would have to translate it in a way that can be used numerically by the computer. So usually they're just categories that this data explain. You can assign numbers to them in order to represent them in a way that the computer can use it. Like gender, for example, male, female, it's a category, right? It's the state where people are from, the race or political party, all these kind of things are just categories that people belong to there. They're just categories. You have to work with that differently when doing machine learning problems. Then there's also ordinal data. ordinal, like their rankings or ratings, right? So it's a mixture of numerical and categorical data. So like movie ratings, for example, rating in different scales and all that can be rating from 1 to 5. The mathematical meaning of this is like, oh, one means that this movie is very poor, or 5 means that this movie is really good. So it's a rating there, but it's really a category also that this movie in 1 are movies that they are very bad. Movie in 5 means that movies are very good, right? So it's like a categorical data that has meaning. Okay, so let's look at this different questions, different kind of data here. So when you say how much gas is in your tank, is this a numerical, categorical, or ordinal data? Let's participate. Yeah.
Emmanuel,
Numerical.
Yeah, let me see. You said? Emmanuel.
Emmanuel,
Yeah.
how much gas is in your gas tank? That is numerical. It can be measured.
It can be measured, okay. A rating of your overall health, where another person should answer this. A rating of your overall health where the choices are 1 to 3. If 1 is poor, 4 is good.
Ordinal.
Okay, Taiwo, thank you. The tribe or state of origin of your classmates. What's that?
Categorical.
Categorical, okay.
Categorical.
Okay, ages in years would be
It's
age.
numerical.
Numerical.
So also numerical. Okay, thank you very much for participating. Okay. Okay, so let's now go to mean, median, and mode. Okay, because sometimes when you load your data to Python, some of the things that you want to see is you want to understand the distribution of the data. So you want to know what's the mean, what's the average, what's the mode, what's very common within this data, and then you want to also see sometimes you want to check what's the median, right? So the mean is just simply the average or the middle, not really median is middle, but mean is the average of the number. So you can see it as mean, or sometimes they'll call it average. It's you just sum the number and then you divide by the number of samples. So we'll do a simple example here. Let's say we're going to Lagos State and we're finding for each family, we'll check for how many children do they have within that household. So let's say some do not have, some have 2, some have 3, some have 2, 1, and all that. So if you have this data here and you check for the mean is just you add all of this and then you divide by 9, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9 households that you've checked here. And the mean tells you this is 1.11. So immediately as a data scientist or as a machine learning engineer, what does that tell you? It says, on average, if you go to a household in Lagos, you're going to see that each family has at least 1 child. On average, some families may not have children like you see here. Some families may have 2 or 3. Some families may have 1. But on average, you're going to see that at least one child, right? So there may even be some that have 10 children, right? But when you see an average of 1, it tells you that maybe that's those kind of families that have 10 children, they are not so much, right? So mean and average gives you an idea of what you would see randomly within the data. It gives you a sense of the distribution of the data. And now let's go to median, because if you have mean, then why do you need median? The median is just the middle of the data. If you have an even number data, though, you may have to add the 2 middle numbers and do the average of that. So the median is less susceptible to outliers than the mean. So what does that mean? Like if you have, like, let's say the mean household income, if you calculate, for example, now we may find that the mean household income of Nigeria, the average income in Nigeria is 500,000 naira per month. That means if we check on average, we're going to see that people earn 500,000 naira per month. But if we go to the median, say, let's just use the middle, we're going to see that it's maybe even less than this, but let's say it's just 50,000 naira. Okay, this also 50,000 naira per month. So why that difference between 500,000 naira and 50,000 naira is because maybe the mean is usually skewed. It's usually going to be higher because of some outliers. There are some billionaires in the country. If you just add everybody's wealth together and average it, you may get that 500,000 naira per month. Because there are some people that are earning very well, and there's some people that are not earning well. But if you just arrange everything and then you find the middle, you will see a more representative value of what people really earn. So there are some times where the mean is good, yes, but there are some times where the median may tell you better because the median is not going to just add up everything as if everybody is the same, right? So the median gives you a better representation of the typical Nigerian household or the typical Nigerian in this example. So that's why median is necessary. So let's check the mode. Mode is just the most common value within the data set. So you look at the data set and it gives you an idea of, okay, it looks like a lot of people do not, like this example we did just now. It gives an example of maybe, oh, sorry, the mode is 0 here. So it's saying that if you look at this, mode is, the 0 here is 4 times, 1 comes 1 time, 2 comes 3 times, and 3 comes once. So it gives an idea of, okay, it looks like a lot of houses do not really have children, even though the average is 1.11. But it looks like the mode tells you, like, okay, it looks like there's something going on there, that there are a lot of houses too that don't have this. So mode gives you an idea of what is most common within this data set. Okay, let's just talk about variance and standard deviation, then we'll take any questions for this section.
Sorry, sir. Please, can you come again? I didn't understand the last part.
Okay, this mode.
Yes, what you explain here right now.
Okay, no problem. The mode is the most common value in the data set. What is most common? So let's say this example, say you have gone to the different household to check how many children do they have. Some have 0, some have 2, some have 3, some have 2, some have 1. This one has 0, this one has 0, and all that. So you now check for each of the numbers here, you check for how many times does it occur within your data set. So if you look at 0, it occurs 1, 2, 3, 4 times. So that's why we put 0 occurs 4 times here. If you look at 1, it only occurs once. If you look at 2, it occurs 1, 2, 3 times there. So if you want to calculate the mode, though there are functions to do this in Python, but if you want to calculate the mode, you just check for, okay, how many times does each of the values within the data occurs? So which one occurs the most here? Which one occurs the most here? Can you answer for us?
Yes, it's
0.
4. It's 0.
0, right? So 0 is the
4
most.
times.
Yeah, so 0 is the most of this data. 0 is the most common value. So it gives you an idea of, okay, it looks like, oh, the average is 1, but it looks like there are a lot of people on the side of 0 also. So that mode also gives you an idea of your kind of data. Okay, is that clear?
Yes, sir. Very clear.
Okay. So the variance and standard deviation. So variance gives you an idea of the spread of your data. So it gives an idea of the spread of your data. It just shows you how much your data differs from the mean. How far is your data from the mean, right? Let me see now if I can use the dashboard, sorry. Okay, so before we go into that, okay, so your variance tells you the spread of your data set, and then standard deviation. The standard deviation is just the square root, right? Maybe I just go, please, mute. Everybody's mute. Don't know if you're in a club.
I'm muted, sorry.
Okay, so the standard deviation is the square root. This standard deviation is the square root of your variance, right? But it also gives an idea of the dispersion of the spread of your data, because just the square of the variance. but it brings the variance because the variance is like average of square differences from the mean. So the standard deviation takes the square root of that so that you can have a scale consistency with your mean, so that you can understand how far is your data spread from your mean. Let me see if I can. So, let me go to wait. Let me just show that in. I think I have a plot here from one of my research material. Let me see. Okay, let's use this one. Okay, so we have let's say we have this histogram here, right? So you look at this histogram here. So let me just explain this plot. This is showing number of people that arrive in a, let's say, a store within every minute, per minute. So sometimes you have nobody coming, maybe sometimes you have one. There are a lot of times. This shows this other axis here, this y-axis shows the frequency, the number of times that this two occurs in the data. It's just like the mode we're looking at just now is just like a plot of it. So if say two people come like maybe 8 times within a minute, 4 people come like maybe 11 times within a minute, then you have some few per year and all that. So if you look at this data, let's say the average of this data, the average of this data would be around 5, right? Around 5, let's say around 5 or maybe around 4 even, right? So the standard deviation is telling you how much data do you have that's far from 4 to the left and to the right. So it's giving you a sense of the spread of your data, how much data do you have that's far from 4. Let's go to the next place and see. Like if you look at this one here, you see that the data, there's 4, it's like 4 is the mean here. Okay, the 4 is the mean. Let's say 4 is the average here, I believe. But if you look at the data, this is so wide, it's so there are some data points that are so far from 4, like 1 year, like 8 year. So there's just a large spread between the data, and we see that the standard deviation is 2.24, right? 2.24 is the standard deviation. So let's say if 4 is if 4 is the mean here, it's probably greater than 4. So if 4 is the mean, it shows that there are some data that's like 4 minus 2.4, some data lower than 4, and there's some data that's also higher than 4 at 4 plus 2.24. So is this clear? I hope it's clear to you. Is it clear? Any questions about this?
Not really clear, but maybe as we go on, maybe to get better.
Okay, yeah. So just so that we don't make it too complex, the general idea is you want to know how much spread you have within your data set. Let's use the example of going to households to check for children again. Let's say if you check in Lagos, let's say in Lagos, for example, you check in Lagos and you go to one household and they tell you they have 20 children. You go to another household and then they tell you they have 1 child. You go to another household, they tell you they have 100 children. You go to another household, they say they have 2 children. Another household, they say they have 1,000 children, right? That data set is very spread out. Like you have different numbers that's so spread out within that data. So that data will have a large variance and standard deviation. But let's say you go to Edo State, for example, and you check one house, so they say they have 2 children. You check another house, so they say they have 2 children. You check another house, so they say they have just 1 child. Another one says 2 children. Another one says 3 children. You see that data, they are very close together. 2, 2, 3, 3, 1, 1, 2, 2. So that data is very close. So it has a small variance or a small difference, if you can use that too. Right? That's why we say it's average of squared differences. So variance is telling you how compact your data is or how different your data is. I hope it's clearer with that now. Okay, Taiwo, can you speak? Is it clear to you?
It's clear.
It's clear, it's clear, it's clear.
Okay, let's move on. The next one now is correlation. So correlation is something that you do a lot when you do like your exploration data analysis. So correlation is like to check the relationship between your data. So correlation is usually between -1 to 1. It shows the strength of the relationship within your data. I'll give an example. Let's say, like they normally say, like smokers are liable to die young. That means when people smoke, there's a likely chance that they will die young. So it looks like there's a correlation between smoking and dying young, right? So that those things have a strong relationship. They are moving in the same direction. Smoking is liable to die. So that's a correlation. They have a correlation. It doesn't necessarily mean that smoking causes death. It doesn't necessarily mean causation, but it means there's a strong correlation. If you look at the data, it looks like these two things are moving together. So there's a relationship here, right? So that's what correlation. I mean, there's a relation. There's a correlation. They are moving in the same direction. We can say, for example, that like if you look at your data, for example, let's say the employee problem we talked about, I think in the first class, let's say a company has different employees. There are people that if their salary is above 500,000 naira, they are more likely to stay long in the company. So there's going to be a strong correlation with staying long in the company and your salary and your earnings. So people that have a high earning there will stay longer. So there's a strong correlation, right? Why maybe people that have lower salaries, they leave, right? So that is also a correlation, but maybe it's a negative, they are moving in a negative direction, right? But there's a strong relation. So you have -1 to 1. So -1 maybe they are moving in a negative direction together. +1 maybe they are moving in the same direction. Positive. So the idea of this is to help you understand that when there's a relationship, we can help, just simple correlation can help you predict, for example, that, if someone is smoking, it means that they are likely to die young. So those kind of things are just simple analysis that you can do to just understand your data better. Okay. Any question, or can anyone give any example of a kind of two variables that move together in society? Any example of correlation that you can share?
Good
Hello,
morning.
Hello, sir.
hello.
Yes.
When the
Go
price
ahead,
of
go.
items,
Wait. Let me just pick someone so I'll talk one at a time. Okay, Gbenga, you can go first. Your name is up here.
okay, I said when the prices of goods,
Mm-hmm.
when they're high,
Mm-hmm.
then the demand, the quantity of that product that will be purchased in the market
Exactly.
will go down.
Exactly.
So that means there is a negative correlation between
Good.
prices and quantity demanded.
Good. Thank you. That's a good one. So that's a correlation. Any other comment? Someone else wanting to speak?
Yes, I want to speak.
Okay.
Taiwo Oladipupo.
Okay.
Yes, Donny Kuru.
Don
Donny Kuru. You know that
yeah.
when people sneeze, if you are sneezing regularly or you have high temperature, they will say you have Kuru. So most people that they even have normal fever, they refuse to go for medical tests then because they said they will not allow them to go. They will say they have Kuru. So those things they were moving together. Then there is a correlation between high body temperature and sneezing with a victim of coronavirus, something like that.
Yes. Thank you very much. So the symptoms show the high correlation. Yes. Shegun will speak. Then
Okay, so the simple example I want to cite is that during rainy season, people tend to buy more umbrellas.
Yeah.
So you are a company that manufactures umbrella, you see that your sale results go up during
Yes.
that season, and then you can be able to see the correlation between the two.
Very good. Thank you very much. So that's also a good example. Yes, Teide, you wanted to say something too?
Yeah, it's just with respect to what is happening. So there's a high correlation between dollar and price in the market now. So as the dollar is rising,
Good.
prices are changing with respect to dollar increase. So
Good. Good. Yeah. So that's a very good example too. So what I want to even do is I want there to be a mutual, just to pause here, I want there to be a mutual formulation of the projects. So I don't want us to just do projects that maybe we just check for data online and then we give you a project that is about American economy or European economy and all that. We're looking for maybe projects that would pertain to Nigeria, right? So within the groups, may start having discussions around what kind of problems can machine learning even solve in Nigeria. So what kind of data can we get? It may be difficult because these are still like the early stages of us really handling data properly in Nigeria. But we can have that conversation to see if there can be interesting projects to do within Nigeria there. Okay, so that's a good example. Those are good examples. So let's go on to, now I want to look at Python NumPy. Easy, simple NumPy, then we'll go into pandas also. So NumPy is just short for numerical Python. So NumPy used to work with arrays, right? Arrays are like array index. When you're selecting an array, it's just like when we did list indexing also. Like this first term will be addressed with 0, second term with 1, 2, 3, and so on. So NumPy arrays are just Python objects that are optimized for mathematical operations, right? So they're optimized for mathematical operations. So let's just see that within Python there. Maybe we should use, okay, we can use our, oh, we're already moving fast today. It's good if we finish it. Okay, let's see, we can use our Python file. We can use our Python file. Let's say we call this first, let's call this array children. Oh, let me import NumPy first. I can do that at the top. So usually import NumPy in Python as NP. As NP. Sorry, I think I have to create a new file. So I create a new file here. Import NumPy as NP. Right. So if you have that, then you can say, let's say children, number of children within families. So if you want to create an array, you have to call np.array. So you see this Python method within array, right? And it's asking for the attributes that it should use. Say, what object am I going to use to create this array? So I'm going to give it an object there. Just now we had, let me see. Let me just copy that list of children, maybe to help. Okay, so we use this one. Let's see this one. Okay, so it's going to give us arrays. Let's print that when we call this file. So print children, let's see. So Python math operations. Oh, so if you do this Python math operations now, it will call this file children, and it's going to give us this array. Let's see what type this array is. Let's print the type for children. Let's see the type for children. It's going to tell you that it's NumPy ND array, right? So the difference between NumPy arrays and lists is this. Usually, though you can create some structured array, but usually NumPy arrays only take the same kind of data type, right? So let's try this and see. Let's say we just put first here, and then we'll put 2, 3. because it's optimized for data operations, it takes the same type of data. Or if maybe you put integers here and you put a float number here, it's going to just convert everything to float type, right? But let's see what NumPy would say if we put. Oh, it actually worked, but it converted. You see that it actually worked, but it converted all of these numbers now to strings. Did you notice that?
Okay.
Because
okay,
2 is now a
okay.
string, 3 is now a string. That's why I put commas. So it convert everything to the same data type. Okay, so that's NumPy. Let's find out the mean of this data. Let's find out the mean. Let's print. You can do NumPy mean with np.mean, right? np.mean for children. Let's check the np.mean for children. So it's going to give you that 1.11 we got, right? np.mean. Let's also do, let's check.
Mode.
You can check the
media.
mode.
Media.
You can check the mode. Let's see. Oh, you say NumPy does not have mode. There's no mode they call it. Let's see what they call it. This is mode. I don't think it's mode. No, this is not the regular mode. It is not regular mode. Oh, no. Anyway, let's do medium. Let's do medium. Not sure.
Hello, sir.
Yeah.
You are not doing it on Collab again.
You can do on Collab. We'll check Collab. We'll check Collab. You can do on Collab. I just wanted to show the basic operations here. So if you do median, the median is 1 for that data, right? So on Collab, you can go. So last time, I don't know if you were in the last class or you watched the video, we used them Visual Studio Code directly, but we can also use this. We can also use Collab here, right? Like we did the refresher with Collab. So if you go to Collab, you can also do the same thing to print everything for you here. To print everything.
Because I'm getting getting the same thing.
You're not getting the same thing.
Yes, sir.
You're not getting the same on Collab. Well. This is it. What's the problem? Let's try to fix that one.
Let me for.
Yeah. Sorry, go ahead, please.
Okay, sir, let me just watch. I think there is a space between children and equals to.
That space does not really matter. That space does not really matter. Please give me 1 minute. I'll be back. 1 minute. Okay. Sorry, you said space before equal to. Yeah, I'm back. You said space before equal to.
Okay, sir.
That space does not matter.
Okay, I've seen that there are 2 equals to sign there before that 0. Maybe that is where the problem lies.
Okay, did you check it out? Does it work?
2 equals to sign from data.
Okay.
I think we're supposed to have 2 equals to sign.
No, you just from here, just 1 equal to 2 equal to is comparison of
2 brackets. 2 brackets.
Oh yeah. This bracket, this one.
Okay.
So you put
there is one for list. There is one for list. Then you have the outer bracket.
Yes, you have to close it. You have to close it. Is it clear now?
Yes, it's okay.
Did you try it? Did you try it now? Have you tried it? Okay, let's try this mode.
Yeah, thank you, sir.
I don't think this is mode in Python. Let me see. That's surprising. Okay, let's do like a Nigerian university lecturer. Go and find out how to do mode as your assignment. Do mode as your assignment in Python.
And that
Right?
one is not difficult. We'll find out. Let me do it.
Yeah. I'm not sure why NumPy is not mode. Okay. So, but let's see the standard deviation. I think it has standard deviation there. So let's do the standard deviation. NP.std. So the standard deviation is std. So let's do that for children. So the standard deviation is 1.09. So if the standard deviation is like this, it's telling you that it looks like the values of children is not too far from the mean, right? Not too far from the mean. But let's change it now to like, let's put some as 30, and let's put some as maybe 20 children. So the mean is 6 now, but let's see the standard deviation. It would be higher. It says 10. So the mean is 6, but there are some values that are very far from the mean. Right? So that's why you have 10 here. Yeah, so when you have data that's different, a lot that's far wide like that, you can get different, you can get a large standard deviation. So let's check for, let's do indexing here. Say children 0, that will give us the first value, which is 0. If you use if you also do 0 to 2, it will give 0, 1, 0 and 1. It doesn't add the last value, which is 2. It just stops at the second value. So just the same way you index lists, that's how you also index Python arrays. But the array comes with this array keyword here, right? Let's add, let's say children from Lagos. Let me just change that to another place. Let's say children from Lagos, then children from Ekiti. So we're trying to add children from across Southwest. Let's say Ekiti have 0, 1, 2, 1, 2, 3, 4, 5, 6. Let's see. So when you're adding arrays like this, it has to be the same number, the same shape, right? The same shape. So if it's six houses that you've checked here, it also has to maybe 6 houses that you checked in the other place, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. I don't have to do that. Maybe we can just do something like let's do Lagos.shape. You can check the shape, right? So shape is what now? Shape is like what? An attribute of this NumPy array object, right? Just like the way we're checking name in those classes, gender, all of those things that we're checking that time, right? So also we're now checking for, okay, what is the shape of this array? It says there are 9 items. There are 9, it's saying that there are 9 items in this array. So let's check for the other one. Children in Ekiti, what's the shape? There are 8. So let's just make that one 9. Let's remove this. So NumPy makes it easy for you to add. You can't do this with lists. You have to do it with a NumPy array. If you add a list like this, it will just concatenate the list. It will just add all the items of the new list at the end of the first list. But with NumPy, if you say this plus this, it will add it up for you. So it will add 0 plus 0, 2 plus 2, 3 plus 1, 2 plus 2, 1 plus 1. Right? It will just add all the terms together. You can also do subtraction here, I believe. It will subtract that. You can also do 2, let's say 2 times children of Lagos. It will just multiply 2 times the values in that list, right? You can do that from the front. Let's also, you can do that from the other, let's see. To also do that, right? So this is because NumPy arrays are optimized for data, not data analysis, for mathematical computation. There are more complex computations you can do with NumPy, but at least we just understand these basic ones for now. Yeah, for now, then yeah, if needed, you can learn more as we go on. Any comments or questions for this?
I want to ask you a question.
Okay, please
What's
go
the
ahead.
difference between arrange and array?
What's the arrange?
And like this, if you do dot np dot arrange or dot
Okay,
and
okay,
dot
okay.
np dot array. I was
Okay,
trying to do that thing, so I was having issue, but I was
okay,
watching it on and I wanted to know the difference.
good. Okay, good question. So let's say you have like so a range, right?
Yeah, arrange.
You're trying to create an array
Yeah.
that is between a range is from one value to another value, right? That's done with NumPy. So let's say you want to create 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? This an array. NP dot, let's say NP dot array. You want to create this. Oh, so all them is, oh, shit,
You have not, you did not assign it to anything.
Okay. No, there's one double comma. So even if you have it like this, instead of you to write it like that, right? Though this is sorry. Instead of you to have it like that, you can use the range because so np dot range.
Okay.
Right? So it's going to ask for the start and stop. So you're going to start from, let's say, you can even just put 10. We want to get a range, you put the stop number, right? So if you say you want to get 0 to 10, it's going to give you, okay, not 0 to 10, it's going to give you 10 values, 0 to 9, right? Because it's going to start from 0. But if you want to start from, let's say, 1 to 10, we're going to stop at, we're going to add 11 here.
11.
So it will stop at 10. Let's see. You go from 1 to 10. So that's what a np.arrange does. If you want
to put step,
yeah, you put it at the last
step. Okay,
yeah,
the last
step
one
will be the last. Say, okay, 0 plus 2 plus that. And I'll just give you all the whole numbers. So this is like a special method now within NumPy, right? It's a special method within NumPy. So NumPy is a class, but yeah. Okay, so that's clear. Anybody has a question?
Yeah, I want to ask
Okay.
what's the difference between array and the NumPy array?
Just array and NumPy array.
Yeah, like just calling an array as a library, like importing an array, working with it, and then importing a NumPy, and then you are still working. So what's like, is there any difference?
Well, I'm not sure. Like, I just know like usually arrays in Python are NumPy arrays, right? Though there are also like structured arrays that you can create and all. So NumPy is the main Python object for managing arrays, and they are made to be fast. So you can do a lot of fast mathematical operations with NumPy arrays, right? There will be other ways that you can create arrays, but they may not be as optimized as NumPy, right? So you have NumPy ND array type. So those are optimized for fast computations and all, but you may have other array types that they are not as fast as NumPy.
Sorry, sir, this NumPy is not a library in
yeah, it's a library in Python. This is the major Python library for managing arrays. Right, this is the major Python library for managing array. Yeah. Does that answer your question? Or do you
Yes, sir.
Okay. Yeah. All right. So any other question? The ladies are not talking, no. It's not, say there are females in the class now. Or they didn't join today.
No.
Okay.
No, we joined. I'm here. I'm following.
Okay. Was it you that asked one time about employee HRO project or no? There was someone that asked about one HRO project.
Yes.
Was it you?
Yes, I was one.
Okay.
Yes, I was.
Okay. So like we're talking about like trying to find projects that may work for Nigeria. Is it something that you have data for, or you're just thinking out loud? Is it something that you have data for? Is it possible to get data for some
No, I because I work in
HR?
so I was trying to see how to put it into my job.
Your job? Okay. That's fine then. Okay. All right. So I just wanted to know. I know someone asked that question in first class. Like the data that we use for today's data analysis, it's more like an HR data, though it's just random. It's just created. So okay. All right. Thank you. So pandas. So pandas is like NumPy, but pandas is more organized data analysis. So it's a Python library that's optimized for data analysis. It gives you a simple way to store big data sets. If you have, not necessarily store, sorry, to read big data sets and then use them within your project. So let's usually CSV files are the most common way. There may be other ways though, but one common way to store large data sets is to use CSV files. So CSV files are comma, I think it's comma separated file, comma delimited file also. So they are just a way that maybe a large data set can be very small because they just remove all the pegs of Excel. So it just made it very simple, just use only commas to separate the data. So with CSV files, which looks like Excel also, or you can read CSV files into Python using pandas. For example, you can import pandas as PD, and then your PD.read CSV, it will load that data into Python, right? So let's just do some simple, we'll do some simple operations with, we'll do some simple operations with pandas on, we can do that now on, we can do that here. On Google Colab. You can also do it on your, sorry, so many things on my file. Okay, you can also do that on your own end. So let's see if it's HR. You can also do that on your, Visual Studio Code. You can do it on Visual Studio Code. Let me see. So now I'm going to read this data into Python using pandas. Import pandas as PD, right? So PD, we can call it data frame df. Let's do pd.read_CSV. HRO employee data.csv. So df. So that data is now in Python. So it's now available for your further analysis. So let's do df dot head. With df dot head, you can look at the head of the data. Head of the data just shows you the first 5 rows of the data. So you look at this data now, it has employee ID, it has the age of the employee, it has the gender, department, seniority level, and so on. So you can also do df.tail, look at the end of the data. So it'll show you the last 5 rows also. So let's go one after the other. Let's leave ID first. What is age is what? Is age what type of data is age?
Age is
Numerical data.
numerical data.
Numerical data. Okay, what of gender? Gender is which one? Okay.
Categorical data.
Categorical data. Okay. What type of numerical data is years at company here? What type of numerical data is this?
Is
Okay.
That is a float.
Okay. Okay. Good. Good. So that's a float or a continuous data, right?
continuous
So this is
data.
continuous because it has decimals within it and all. Yeah. So performance rating is which type of data?
Integer.
Yes, it's integer, but
Integer.
the kind of data we talked about today. There's one other one. Yeah?
Ordinal.
Yeah, yeah. Okay, so it's an ordinal data rating, right? So it's ranking their performance on the job. One being poor and I think 4 or 5 being the highest. So you see how you can just have a glance at your data that was stored in CSV. You can see that within Python here. Within Python, and then you can go further and just analyze the data. So let's now go into, let's just go into, just give an introduction to exploratory data analysis. Then, then maybe we'll just go further on the data and then we can wrap up. Analysis. Okay, so exploratory data analysis. So, like we said, the code that we started with today, there's no information without data, but you can have data without any information, right? So exploratory data analysis is an approach that employees it uses a variety of techniques. So you are going to try to maximize or get insight from your data. You are going to understand the underlying structure of your data. You are going to be checking for outliers, anomalies. You're going to extract important variables or important insights also. You may visualize your data, just check how the data looks like. You may check the correlations between your different variables within the data. Exploratory data is what, when you do exploratory data analysis, sometimes that's when you may uncover some possibilities or some of the models that you can even test. It can help you identify your target variable. It can help you identify what you are trying to predict or which model will even be best suited for your data. Exploratory data analysis is not something you can joke with. I remember one time on one of my first roles as a data scientist where when I got in the company, because I've been practicing and doing some Udemy courses before the job. So I just thought exploratory data analysis is just something that I would do for 1 week. So when my manager showed what we're going to do for the year, she said we're going to spend about 4 months on exploratory data analysis. I was shocked, like, why do we have to spend 4 months on this thing? It's just 1 week now, we'll get the data. But when we started doing it, I saw the value in it because the data was stored in a database where you had to pull several tables together, understand all the different columns within that table. And then when you're now, there are times when you would do like SQL statements. SQL is structured query language. So the SQL statements, you are going to join different tables to get your data that you use for your model, right? So exploratory data analysis helped us understand all the tables within their database and then now start finding, okay, these are the models that we can build based on all of this data. So exploratory data analysis can take time. It's not something that you just glance over and know. It's very important for building models in machine learning. So the key techniques in exploratory data analysis, the key things you will see there is you may have to do like descriptive statistics. Check your mean, check the median, check the mode, check the variation or variance, the correlations and all of that. So you need to do some descriptive statistics. You may need to do some visualizations to use plots, use graphs, use patterns, see what's happening within your data. You may need to also do correlations. You may not need to also do dimensionality reduction. Depending on the kind of data you have, you may need to, if there's too many features that you need to use, you can reduce that with dimensionality reduction methods. We may talk about that in unsupervised learning. Then finally, you can handle missing data. So if there's some missing data on your data, you may have to find ways to fill that up. or just totally delete the column or delete the rows, right? But sometimes it's good if you can handle missing data by just filling them up. Okay, Ifeanyi, you have a question.
Yes, sir. Sir, sorry to take us back. I want to know what's the meaning of outliers.
Oh, okay. Okay. Thank you for raising that up. Thank you. Yes. So outliers are so outliers are you have like a mean, like usually it's values that are very far from your mean, right? So let's say we have the mean, the average of household children is 2. Some people have 1 child, some people have 3 children, some people have 4, some people don't have. So these are what is common within the community, right? But then you now see somebody that has 20 children, right? So this is what you call an outlier, right? Sometimes this outlier here may not help you in predicting properly. Like we said just now, we're saying that in Nigeria, let's say the average salary, the middle salary earner is actually 50,000 naira. Let's say 50,000 naira per month. But if you do the average, you may get like, let's say 500,000, 500K, right? So there are some people that earn 20K, some people that earn 10K, some people that earn 100K and all of that. But there are some people that earn 1 billion, 2 billion, right? So these are outliers. There are not so many in the society. So they can skew, there's something they call skew, they can skew your mean. They'll drag the mean to this side. You would think, oh,
Hello?
people actually earn a lot,
Hello,
right?
Fiam.
Sorry, you have to
You
mute.
can go there, Colin.
You have to mute, please.
Ọ̀la kọ́ ni 12, Monday ni 12.
Okay, so what we're saying here is outliers are just values that are very far from the mean, right? So you can detect them by checking how far they are from the mean. Sometimes you can say, oh, any value that's the mean plus maybe 3 standard deviations or something, 3 standard deviations, any value outside of that range is an outlier. Okay, does that make sense?
Okay, sir, that's clear. Thank you.
Okay. Yeah.
Hello, sir.
Any other questions? Someone else?
Hello.
Yes.
Just to contribute to that outliers, we can
Yes.
also call it extreme values.
Good, good. Yeah. Yeah. So you can call it
That's
extreme values, right? Yeah. Okay. Any other thing? Any other person wants to comment on that?
Hello, good morning.
Yeah, good morning.
Yeah, so the comment I will give is based on my kind of job. You know, I'm an M&A deals analyst. So if I want to value a business,
Okay, good.
and I've been able to identify proxy companies like similar to that, and I want to use the value of those companies to value the particular company I'm working on.
Yeah.
And let's assume that I've identified 10, and out of the 10, maybe they are between 1 billion, 2 billion, 1.5, 1.8. And then we just have like 2 of them that are 20 billion, even though
Yeah.
they are within the same sector. And some are just like 100,000 or very, very low. So
Small.
what we do
Yeah.
is that those ones are considered outliers, and they
Yeah.
will have to be removed from the data set because it's going to affect the results.
True. True. Yeah, yeah. Very good example. Thank you very much for that. So those extreme values, it can skew your results, it can affect your analysis, so you can just take them out. Or find a way, or find ways to handle them within the data. Sometimes you can just replace their value with a value within the range for like time series analysis. But yeah, we'll come to that. When you get your project, you're working on your data set, you may handle some of these things. Okay. So now the tools that you use for Python for experiential data analysis, you can use pandas, right? So pandas for data manipulation analysis. can use NumPy for computing. Then you can use Matplotlib for visualization. Matplotlib. You can use Seaborn. Seaborn is a high-level data visualization. So Seaborn is a wrapper around Matplotlib. So there are some, it can give better visualization sometimes than Matplotlib. Then you can use SciPy. SciPy has some statistical, like I believe SciPy will have the mode, mean and median stuff that we're checking for just now. So SciPy has some good stats, statistical.
Yes, it has it. I've checked. It has the
Yeah.
mode.
Okay. Yeah. Good. Then scikit-learn. Scikit-learn has a core package for machine learning models in Python. So that's scikit-learn. Yeah, so these are the tools that you use usually for your exploratory data analysis. So scikit-learn has tools that would help you like handle missing values, or tools that will help you like scale your data. So all of these different things. Yeah. Okay, so that's it. That's it. Let's see our data again. So next week now, let me just say, we'll go through data in pandas again. But next week we'll now I wasn't sure if we'll get to the last slide today, but I'm grateful we could get there. So next week now we'll now discuss on framing a machine learning problem. Hopefully we can start discussions on your projects by next week. But there are some discussions I want you to have within your group. Within your group, I want you to have discussions about what kind of projects you can do. I have some, but I don't want to just throw that at you. Let's discuss the kind of things that are happening in Nigeria that we can get data on. There's some data on the Nigerian Stats website. Is it nigerianstats.gov or so, something like that? You can get some data there, but let's still hear your idea so that we can get something that's interesting to you and interesting for me too, so that we can work on that. But next week we'll be looking at, we'll go more into the exploration data analysis proper, but we also do framing the machine learning problem and just some business understanding. Then by the upper week, we can start our supervised learning. That's week 6. So let's go back to this data. So you can see this data here. So you can check the data types with NumPy, with pandas rather. So we've already loaded the data into DF, so we can check df.dtypes. So that will give us the data types, right? So I'm just showing some basic things. Yeah, I'm just showing some basic things that you can do with pandas. We'll go into more detail next week. Okay.
Yeah. Please, I have a question.
Okay, please go ahead. Yeah.
Yeah. So is it possible for one to want to like do project alone without being in a group?
Interesting. It's yeah, I think there can be some flexibility with that. It doesn't have to be that, because you may have a project that, yeah, I think that should be okay. That should be okay. Yeah, you can do that actually. Yeah, if you have a project in mind that you want to work on, you can do that, though it's more work for the facilitator, because I would like to have meetings with the groups one-on-one, right? But I now have to schedule a meeting for that individual personally. So that's fine. I think the most important thing is to create projects that have value for you and for the program in general, right? So yeah, I think that would be, yeah, if you have an interesting project you want to work on, yeah, that would be fine actually.
Okay.
Yeah. Anyone with that same thought?
I have question.
Yes, please go ahead.
Yes, I'm thinking, I don't know if I'm right, that this machine learning is more of data analysis, where we can get useful information, maybe to solve problem, maybe to help country, or depending on, what we need to have a group of data that we are going to use, and from that data, once we begin to do the analysis, we can come up with useful information, either to address problem or to come up with a new project or something like that nature. And that's when we are going, I mean, that's when we begin to apply all these pandas and all those methods that we have learned.
Okay.
Am I right?
Okay. Yes, yes, yes. So the yeah, so it's the exploration data analysis is part of it. It's a key part of it, right? Very important. Then now processing that data, export the data, process data, and then building the model is also an important part of it, right? Because you're going to use some models to make predictions. So that's also important. And being able to select the right model, depending on the kind of data you have, is also very important, right? But one key thing now that if that part of the whole puzzle is not correctly put in place, everything just crumbles, is even the data collection. Where are you going to get the right data to use for this thing? If the company or if the country or if the wherever you're going to get your data for, if they're not keeping their data properly, then it may be difficult, right? It may be difficult to even explore the data or even make any sense of the data, right? So it's data collection is important as exploration data analysis as much as building the model also. Yeah. Yeah, thank you. So if yeah.
Okay, sir. My question is, in the data type you just displayed, what's the meaning of that 64 attached to int?
Yeah, yeah. Okay, good. Yeah. So Python has different data types. We talked about the last time, integer, float, right? So we understand integer, float, then even object. Objects is like a string. Yeah, in pandas, you would get object type for strings. So 64 here, it's just like you have 64-bit laptop, 32-bit and all. So it's just the amount of data that's kept in the memory for this particular variable, this column, right? So int 64 means it can keep up to, I think 2 to the power 64, I think 2 to the power 64 integer values, right? So it just whether it's 2 to the power 64, 64 length, in a number of lengths of 64, it just means that the size of the data that this can store. If you make it, let's say int 6, for example, now. Sorry, I think it's int 8. Sorry, int 8, int 32, then int 64. Int 8, for example, now may not be able to store 100,000 or 200 or 1 million, for example, right? Int 64 may be able to store up to 10 quadrillion or something like that. So it just tells you the size of how much data can be stored within that particular column. Yeah.
Okay, sir.
Yeah, 64 is the highest for now. Okay. Any other questions there? I think we can close early today. So df, you can also do df.info to give you info about the colons. Sometimes here you would see it's saying non-null, right? How many numbers are not null within that column? So you see here that we have sorry, I didn't do the, I think you can do df.shape also. Let's see. So df.shape is showing us that we have 14 columns and 1,000 rows. So 1,000 rows, see all of these values here, none is missing. Null means if you now see maybe one column age is now 600, it means that some values are missing. Yeah. So giving us 1,000 in all the rows means that no value is missing there, no value is missing, right? So df.shape, df.info. Then there's also you can do, I think we talked about df.describe before. That would, so describe would now take all of the numerical columns. It take all the numerical columns and then give us some description about them. Though employee ID is not supposed to be an integer or something, but because it's stored employee ID as integer, so pandas will just still do the analysis on it, right? But the average age of the workers is about 39 years. The standard deviation is about 11. So they have people like maybe 50, that's 39 plus 11, like 50. Then they have people like maybe 39 minus 11. So that is spread around the mean. That's standard deviation. You see that the lowest age here, minimum value is 20 years, 20 years of age. The 25th percentile, we talked about this in the last class. It means that about 25% of the people that work there are around 29 years and below, while the other 75% are above 29 years and above 29 years, right? Then the 50 percentile, which is the mean, is also 39 years. So you can see they have a pretty young, maybe, don't know, depends on age, whether old or young. The maximum is even 59, right? Retirement age in Nigeria, and I think is 65 or so. For judges, maybe like 70 or 75. So they have a decent workforce. So years at the company, they have people that stay long, 15 years. The lowest is maybe half, just 0.5. So the maximum is 29 years. So the oldest worker in the company is 29 years that has worked with the company, or she has worked with the company. So we see that we're just looking at this and we're getting some idea. You're just looking at the description here and you're getting some idea about the company already. Let's just do one plot. I'll do more next week. So df, I think df.plot. Let me see, I can select a column like this. You can select a column. Let's plot the annual salary. Let's see. Okay, not 2 nines, because this is Pandas plot uses matplotlib. And this was a random data actually. Let's check age, how age looks like. Okay, it's also random, so that's not nice at all. All right, so hopefully by next week we'll use a more representative data. I just want to use this to just play around and understand data analysis. Next week we'll use a different data. Yeah, I think we can stop here for now. We can stop
I have
here.
a question.
Yeah, let's take questions and wrap it up. Yeah. All right, please go ahead.
Yeah, I just want to, it's somehow difficult to maybe to cram most of these functions and this. So I want to know, how do you know that when you are calling a library, let's say, let's assume Pandas is the library which you are calling.
Yes.
How do you know when what you are using is a method or it's just an attribute? Because I see down there when you are trying to
Shape.
use ship, and when you are trying to use the describe, the way you use them are different.
Yes.
Because of the brackets, that's the last brackets attached to ship, and then the other one attached to So when should you? How do you even know? Okay, I'm trying to use ship. Is ship a method or is ship an attribute that I will add? I don't know whether you get my questions.
Yeah. I get you. So I would say first, like it's so just generally first, it's when you need an information about your data frame, it's an attribute. When you're looking at for information about maybe let me see, like data types. What is data types of this data frame? What is the shape of this data frame, right? When you're looking for an information about the data frame, that's an attribute of the data frame, right? When you want to perform some operations to get more information about the columns within the data frame, then it's a method, right? Because this describe now, we're using brackets to get more insight about the columns, right? Info here gives us more insight about the columns. So depending on if you are if you're going to perform an operation on a column, it's usually a method, right? But and also, like, sometimes there were times when I used to write Python and I'm doing shape bracket. When I press and I see that, oh, there's an error, okay, and I'm like, okay, it's an attribute, let me just get to like this. So sometimes also about usage. As you are using it and doing more data analysis with time, you will just know it. But there are also times when, so some codes we just have to check Google and, and refresh. But at least once you have used it, you're going to get some general idea about how the thing works. Then sometimes too, you can actually just check Google to find out, okay, how do I do this? How do I get that? And but usually it's with usage. As you use it, it will become more a part of you. Yeah. Yeah.
Thank you.
Okay, welcome. Any further questions? Okay, so I think we'll wrap up here. I'll stop the recording now. We can take other questions concerning the whole program and all. But let me wrap up here so that people can just focus on learning rather than other discussions.